Alright, so midterm problem solving walkthrough, we are going to be solving a math counts problem, which is some number theory with some probability. The probability part isn't too much. You don't need to know that much probability. You don't even need to know the basics, basically. So, I mean, if you know the basics, that would be great, but let's just get started with this number. This is basically a number theory problem. So a two-digit prime number is randomly selected. What is the probability that its digits sum to 9? So essentially, we want a prime number whose digits, a two-digit prime number whose digits sum to 9. So, we need to find, okay, so for this problem, we are going to ignore the primes, alright? Sometimes in number theory problems, you have to ignore what you want to get what you want. And this is kind of like the counting strategy we use in some other videos where we count what we don't want. Here we're going to count something totally unrelated, something related, but we're counting what we like, something without restrictions, basically. So right now we have a restriction that we need a two-digit prime. This prime makes things harder. So what I'm going to do is I'm going to construct integers that sum to 9. Alright, so let's just get started. So first we're going to do 1 plus 8. They sum to 9. We have 18. Now we know how this is going to go. We go to 2. 2 plus 7 is 9. We have 27. Now we move on to 3. 3 plus 6 is 9. So we have 36. Now we move on to 4. 4 plus 5 is 9, so we have 45. Move on to 5. 5 plus 4 is 9. We have 54. And now we go to 6. 6 plus 3 is 9, so we have 63. Now we move on to 7. 7 plus 2 is 9, we have 72. Move on to 8. 8 plus 1 is 9, we have 8. And we move on to 9. 9 plus 0 is 9. And then obviously once we hit 10, that's three-digit numbers, which we don't want. So this is every single two-digit natural number whose digits sum to 9. This is every single integer we've already found. Now 18 is composite. 18 divided by 9, and we have 6, we have 3, a multiple. 18 is also a multiple of 2. 27 is a multiple of 3. It can't be prime. 36 is composite. 6 times 6 is 36. 45 is a multiple of 5 and 9, so it's composite. 54 is composite. It's a multiple of 6 and 9. 63 is composite. It's a multiple of 9 and 7. 72 is composite. It's a multiple of 72 is actually a big one. We have 12, we have 2, there's lots, we have 9, we have 8, multiple of lots of things. 81 is obviously a composite number because it's a perfect square. 81 is a perfect square, so 9 squared is 81. So 81 is definitely not a prime. Now we go to 90. 90 ends with a 0, so we automatically know it's not going to be a prime number. We all obviously already know that because 9 times 10 is 90. That's the first thing I think of when I see 90. 9 times 10 is 90. So it seems like none of these is prime. And you might be thinking, well, it's not going to be 0. In many math problems, 0 is a very uncommon answer. But in this problem, the answer happens to be 0. Because we have these integers. Okay, so we have these 9 integers. These are all the integers whose digits sum to 9. And none of them are prime. So what we've done is we went to the second step of the problem. We worked backwards almost. And we went to something that's not necessarily related, and we found the answer. Now, this is the only fast way I can think of finding a solution. The other solution would be to list out every single prime and see which digits sum to 9. But obviously, you'd be wasting a lot of time since, especially in math counts, you're supposed to do it pretty quick. Like, there's 40 questions in math counts, and you're supposed to do it or 30 questions, and you're supposed to do it in 40 minutes. So, I mean, this falls probably into the easy question, or maybe like the harder ones at the end. So you for a quicker solution, go to the quick solutions. Don't do the hard way, even if you think, if you're completely desperate, then do it the hard way, but this is how you would solve such a problem. You would focus on the stuff. If you don't know the solution to a problem, read the problem again and go to another part of the problem. Like right now, if I didn't understand this, I would go to another part. The other part is the probability that's digits sum to 9. And we didn't even need probability in this thing because we know it's going to be 0%. There's no way. If there's no favorable outcomes, we won't have a probability. So that's how you would solve such a problem like this. Hopefully this video is helpful, and yeah.